All right, so what we're going to do is we're going to start off with a little review of log. So we're going to do log base 5 of 8 plus log base 5 of x equals, we'll say log base 5 of 2. All right, once you guys solve that and put in your answer, see what you think. Okay, so remember when you combine these two, when you're dealing with logs, um, we want to combine the logs if you have more than one on one side of the equal sign. So in other words, here's the equal sign, right? And I've got two logs on this side, so let's combine those together into one. And remember that if you add two logs together, you combine them by multiplying the a values, right? So a times x, that'd be 8x, equals log base 5 of 2. All right, and now when I have one log on one side and another log on the other side, and they are the same base, I can just drop those logs off and set the a's equal to each other and solve that. So then I can divide that both sides by 8 here, and that would simplify to be 1 over 4. So x equals 1 over 4. Okay? All right? Okay, now let's look at the same problem, or at least very similar. Log base 5 of 8 plus log base 5 of x. But now it's just equal to 2. Not log base 5 of 2, but just 2 itself. Right? So go ahead and solve that. Now remember, I can't just cancel the logs this time, right? So now I've got to change what it looks like. Hint, hint. I got to change the form. Okay? All right, so what we're going to do here first is same thing like we did in the last problem. Combine these two, right? So we get log base 5 of 8x equal to 2. And remember that this is in log form. So log base of a equals z, the base being 5, the a being 8x, and the e being 2. And we could change this into exponential form. All right, so now the b is the 5, the e is the 2, and the a is the 8x. And now all we have to do is simplify that and solve it. Remember, this is all you do is do 5 squared, get that, and then divide by 8. Okay? Okay, a little review from the day before. I want you to take this graph I'm about to create, and I want you to write out the equation. All right, so it crosses there, and there, also crosses there. All right, so remember with this one, you need to find the roots, pick the y-intercept, and then you're going to set up the equation with the a value. Remember that when you write out the factors from the roots, that you're going to change the sign there. Check for any double roots that you might have, and then solve for a as the first step. And then once you find a, then plug the a in right in front of the equation, right, and then write it out. Write out the entire equation. Okay. So once you get that, write the whole thing out, including a. You can keep it in factor form. Hint, hint, if there's any double roots, remember that you want to put a square. Check out yesterday's video if you need some review on that. Okay. Now we're going to get to sine. Okay, sine and cosine, which we've been talking about the last week or so. All right, so let's say that I've got this graph, and right here, this is 180. That means this will be 360. So we're going to make some tallies or some marks every 90 degrees. And then right here, we'll just go by ones. Okay? All right, so what we're trying to do here is we're trying to graph. All right, so I'm going to start off with, let's graph sine. Y equals sine of x. All right, in order to graph that and understand what to graph, I'm going to draw a quick little sketch of a unit circle, right? Remember when we start over here, and remember the unit circle is on an x and y axis, right? So let's just put a little quick axis. Here, when we start at 0 degrees, the coordinate for that point is 1 unit over, so it's 1 and 0. This point up here, when we go to 90 degrees, that's at 0, 1. And then over here, we're over at -1 and 0. Down here, sorry, and that's when we get to 180 degrees. Here at 270, we go down to 0, -1. All right. Now, and then when we get back to 360 here, then we're back to 1, 0. Now, when we're looking for the points to graph for sine, remember that sine is all the y values in the unit circle, right? So if I start at 0 degrees, the y value is 0, meaning that I start right on the axis. Then when I get to 90, it goes up to 1. So 90 goes up to 1 here. And then as I go to 180, now the y value becomes 0 again. So at 180, I'm going to go back to the middle line at 0. And then for 270, I go to -1. So that means I go below the line this time. And then when I get back to 360, y is now 0 again. So now I get this wave that kind of goes up, comes through 180, back down under 270, and comes back here. All right. Then what about cosine? Okay, cosine, very similar, except now we're following the x values as we go around the unit circle. So now we start at not 0, but we start at 1. So here, I'm going to go up above the x-axis first at 0 degrees. Then at 90, we go back to 0. At 180, we're at -1, so I go below the x-axis here. At 270, we're back to 0 again. And then at 360, we're back to 1. So 1 unit above. So now it kind of starts off at its peak, comes down through 90, bottoms out at 180, goes back through 270, and comes back up at 360. So that's what sine and cosine look like, right? But then we start doing things like this. We start adding in, 2 times sine of x, or let's say 3 times cosine of x, and then we also add a 1. So now we're shifting this thing and changing the amplitude. All right, so what I want you guys to do is graph both of these functions. Start with this one, graph 2 times sine of x. Remember, that's changing the amplitudes, right? So basically, I'm going to graph this same graph, this sine right here. Remember that this one right here that starts in the middle, right here, that's sine, and this is cosine. Graph that. All you're going to do is change the amplitude. So that means that 90 degrees will be 2 units above, and 270 will be 2 units below. Okay, and also graph that cosine function, which the amplitude will change. But first, make sure you start with that vertical shift. Again, check out yesterday's video for review over that. Okay, so do those two. All right. Okay, now lastly, we're going to talk about how to build a function. All right, and the different important parts of the function. All right, so here, the different numbers you guys put in around the function, whether it be sine or cosine, okay, have different names or letters. Okay, so the amplitude, that's A. The vertical shift is D. The B value will be any number that goes in front of the X inside the parentheses. And then there's one more, the C value, which causes this thing to kind of shift left or right. Okay, so let me start a graph. And we're going to figure out all those different parts. All right, so I'm going to kind of cut this down a little bit. I'm going to graph this here and here. We'll put 90 right there and 270 here. So may shrink it down just so I have more room over here to work. All right, and we'll make this actually, we'll say this is 2 units here from there to there. All right, so let's just say that my graph does this. Starts here. Actually, let's say it does this. Let's say it starts right here. Okay. And it goes up to here and comes back down and then goes down to here and comes back up to here. Okay. And then it kind of just repeats itself, right? All right, so now one full period of this goes to 360, right? Now notice the midline of this function is right here, right? It's not right on the x-axis. The midline of the function is actually at positive 1, all right? So given a graph, create the function. All right, so first, amplitude. Well, count the amplitude. Well, there's the midline, right? So from there, that's 1, that's 2, that's 3, so the amplitude is 2 units. Okay, then the vertical shift, it went up 1, that is the d value, plus 1. The b and c is the next part, okay? So now the b, what that does is it helps us determine the period of your function. And remember, the period is how long it takes for this thing to repeat itself. So you can see one full period starts here, comes up, goes down, comes back to 360, and then starts that wave again. Okay. The C determines whether there's a shift, like moving left to right. Okay. So here, to the B value, well, we need to look at the period. All right. So now the period is 360 degrees. Okay. If the period is 360 degrees, we find the period like this. Period is equal to either 360 degrees divided by B or 2 pi divided by B. Okay. So 2 pi divided by B. So basically, I already know that the period is 360 degrees, right? So I'm going to set up an equation to find the B. So 360 degrees is equal to 360 divided by whatever the B is. Now, if you think about it, what number would you divide by 360 to get 360? Well, that's just 1. So the B is just 1. All right. Now, for C, I would look for a phase shift. I would look for see if, like, does this sine, especially if it's sine, does it start somewhere different? Does it start at 90 degrees instead of at 0? Or does it start at 180? Is it like shifted a little bit? And in this case, it hasn't, because it's still starting at the y-axis. So that C is going to be a 0. So when I put this together, y will equal first the A times sine, then the B, which is just 1, so all I need to put is x, and there's no C, so all I need is x there, and then plus 1. So that's all that function is for that one. Okay? Now, what if I've given the equation? Okay, and you guys pack it for 9.8, you guys start off by having to find all these different values by just looking at the equation. All right? So let's just say I've got 3 times the cosine of 2 minus pi. So look, now there's a value there. And then minus 2. Actually, let's go minus 4. So first thing you want to do is the question that it asks in this homework packet is it asks you for the amplitude. You got to find the vertical shift. You have to find the period and phase shift. And then it also asks you to find if there's a reflection or not. And if you guys remember, if reflection just means it's going to flip, right? All right, so let's first start by finding the A, B, and C. Okay, so now for A, well, it's 3. B, 2. C, pi. Okay, and negative 4 or down 4 for the phase shift. Now, the amplitude is just 3, right? The vertical shift is the D value, so minus 4. But the period has to be found using the B value. And also the same thing with the phase shift needs to be found using the C value. All right, actually the C and the V. So let's start with period. Okay. So remember what I just told you, that the period goes every 2 pi or every 260 degrees. So what you do is you basically take that and divide it by B, or 360 divided by B. Now notice that right here, that this says minus pi, right? So if it says minus pi, that means that we're dealing with radians. So you're going to want to use this option. So if you see pi there, or any type of fraction of pi, use 2 pi over b. If you see like minus 180 or 360 or some kind of degrees right here, then use 360 over b. All right, so to find the period, I'm going to do 2 pi over the b value, which is 2. These cancel, and so the period is equal to pi. So basically what this graph does is it repeats itself every time it hits pi, okay? So in other words, these cosine graphs look like this, right? So the beginning and the end, the distance would be pi, the middle would be half pi, which is normally would be 2 pi on the end and pi in the middle, okay? But it's basically shrunk or squished horizontally. Okay, now the phase shift. How much did it move left or right? Okay, so what I do is I take the bx minus c part of the equation and I set that equal to 0. And when I solve for x, that's going to give me the phase shift. So first thing I want to do is add pi to both sides. I get 2x equals pi, and then divide by 2. And you can see that x equals pi over 2. So the phase shift is 2 to the right. 2 to the right. And that makes sense because, it's pi over 2 to the right, so half pi to the right. Remember that when this is negative, that the shift is actually positive, or it means it goes to the right. So I don't know if you guys remember that from transformations. So here the phase shift would be pi over 2. Okay. Is there a reflection? No. I would see a negative in the front if there was a reflection. Okay. All right. So the problem I want you guys to work on now is let's write down the A, the B, the C, and the D, and find the period, find the phase shift for -2. Actually, let's just do 2. 2 times sine of 4x plus pi plus 3. Okay, you guys figure out amplitude, vertical shift, period, phase, and does it reflect? Okay. Okay, let's pick a little bit different one. Okay, now let's say it was -5 times sine of, let's say, 1/2 x, then minus pi over 2. Actually, let's go pi over 4. Make things interesting here. Okay, so first, A, B, C, and D. Your A is going to be 5. Remember, don't include the negative. Negative doesn't affect your A or amplitude. B is going to be 1/2. C is going to be minus pi over 4. And then D is -1. Okay, I'm going to start off by writing down the amplitude, which is 5. The vertical shift goes down 1 or -1. Now let's find the period. Okay, I noticed pi there, so I'm going to do 2 pi over the B over 1/2. Now, I'm dividing a fraction, right? So I don't want to write it this way. I want to write it side by side if I'm divided by a fraction. And if you remember, what you do is you flip, right? And change it to multiply. So now it's really just 2 times 2 pi. Or 2 pi times 2. Okay, so that means the period is actually 4. So the period is 4 pi. That means it changes, or it repeats every 4 pi. Okay, now the phase shift. Okay, the phase shift, remember we take this part of the equation and set it equal to 0. So that'd be minus pi over 4 equals 0. All right, so first thing I want to do is I'm going to add pi over 4 to both sides. Just like I added pi to that other equation. And notice it says 1 over 2 times x. I can also write that as x over 2 for ease of solving equations. Kind of makes things a little bit easier. Okay, so now I got pi over 4. And now I just need to get x by itself, so what I can do is multiply 2 on both sides. cancels there. And now we have 2 pi over 4, which I can reduce that to pi over 2. Okay, so that's the phase shift, is that it's going to move pi over 2 to the right. Okay, so that's how you do that. So the one I want you guys to do is let's do, oh, and one last thing. There's a negative there. So that means there is a reflection. So I'll just write that in there, okay, that there is a reflection. All right, so the one I want you all to do is let's do negative 4 cosine times pi over 4 x, and then we're going to go plus pi over 2. And then, sorry, I'm squishing this, minus 3. Sorry about that. So negative 4 times cosine, the b is going to be pi over 4x plus the c is pi over 2, and then minus 3. All right, so I want you guys to find all the values for that and then write that in the puzzle. And don't forget to include that in your notes. Okay? All right, that's it. Okay, I did forget to include one thing here. So for the homework, okay, you'll notice that the equations up here are very similar to the ones I just showed you. Okay, so you're going to be looking for the amplitude, vertical shift, phase shift, period, and any reflections. Okay, then down here, kind of like that example I showed you a minute ago, you're going to figure out the equation looking at the graph. Now, what I want you guys to do is this. It says write the sine graph for each of these, but I'm going to change that up. For this one, I want you to write it as cosine. For this one, I want you to write it as sine. For this one, we're also going to do cosine. So don't pay attention to this part. And then here, we're going to do sine. Okay? So I'll help you guys out with this first one here. So, and let's zoom in just a little bit more there. Okay. So I'm going to create the equation, right? So what I'm going to need, I need the A, I need the B, I need the C, and the D. All right, so here, the A is the amplitude. Well, first, let's find the midline. Okay, the top is 5, the bottom is negative 3. So that's 8 units in between that. So that means 4 units down from 5 should be the midline right there. Right? Okay, so that means that from there, there's the amplitude, 4. Also, that's the vertical shift, plus 1. All right, now we got to figure out the B value, okay, the B value. So now remember, this is cosine, right? So first, to figure out the B value, let's figure out the period of how long does this take to repeat itself? Well, notice it starts right here. And then to get back to this peak, or this valley right here, it takes 180 degrees from 0 to 180. So that is the period. Not the B value, but the period. So the period equals 180, right? Now, remember what I told you, that in order to find the period, you take 360 or 2 pi and divide it by B. So we're going to use that to be able to find the B value. All right, so that means that if I took 180, or if I have 180, what I did to get that was take 360 and divide it by the B value. So you have to think, okay, what did I divide by 360 to get 180?
ECB student.
Well, if you can't see it,
now closed. You must go to an after.
Okay, so basically what I could do is put this over 1, cross multiply, 180b equals 360, divided by 180 is 180. And so that means that b equals 2. All right, so there's the b. Now what about the phase shift? All right, well, phase shift, I need to look at the graph and say, okay, well, if it's cosine, remember the cosine starts at the top, right? And it kind of comes down. Notice how it doesn't start at the top. It actually starts like over here, right? So it starts over here at 90. Now you can do one or two things. I could say, okay, it starts over here 90 degrees away from here. All right. So since it starts way over here, that means that when I find the phase shift, let's say if I had the equation, kind of like these problems here, if I find the phase shift, then actually, let's make this a little easier for you guys. Let's skip on the phase shift for these problems and just focus on, okay, well, if it's cosine, usually this peak would be up here. So in other words, it basically got flipped. So if it got flipped, so basically don't worry about C, that means there was a reflection. That means there's a -1 in front. Okay, so for instance, this one is sine, right? Sine's supposed to start in the middle and go up and then come down. Here's another cosine. See how this one starts at the top and then goes down first? Whereas this one starts at the bottom and then goes up, right? Okay, but it doesn't start in the middle. If it started in the middle, that'd be sine. If it started at either the top or the bottom, that's cosine. Now look at this one. Here's the midline, right? Well, it doesn't start at the bottom. It doesn't start at the top. It starts right in the middle. So that way we know it's sine. All right. But sine is supposed to go up and then come down, right? But this goes down and then comes up. So that means that this is also going to be a reflection. No reflection here because it starts at the top and goes down. All right. Okay. So here, since we have a reflection, that's it. Now we're going to write the function out. So now y equals first your a times cosine of b, which is 2 times x. We're not going to write a phase shift, and then plus 1. But because there's a reflection, I also need to put a -1 in the front. Okay? All right, so that's how you do those. And on the back side here, basically what you're doing is you're focusing in on this triangle and solving, you're focusing on this triangle, which is created by this angle right here. You can see the angle going all the way around, and it's asking first to find. Says the curved arrow represents the rotation of OR. Oh, and I'm sorry, by the way, skip these guys. Don't do 11 and 12. I said that in the assignment too. Skip those because those are just too hard to do with what we're teaching you guys. Okay. It's actually kind of it's difficult for me to do, to be honest. Okay, so the curved arrow represents the rotation of OR beginning from the positive x-axis. So in other words, this OR, this line, is rotated all the way from here all the way to here. And it's saying through how many degrees has it rotated? So what degrees is that? Well, it tells you right here that ROS, in order where it's this angle, is 60 degrees. So if that's 60 degrees, okay, meaning that from here to here is 60, guys, what would the angle be all the way around to here? Okay, so that's what you're going to put there. If OR equals 1, in other words, this side equals 1, what are the exact length of OS? In other words, this side, and SR, so this side. So if I was to pull this triangle off to the side here, here's OS, here's SR, and it says OR, which is this side, is 1. Actually, let me label it. I think that makes more sense. Let's do O here, S here, R here. Here's OR, right? That's 1. It's asking you to find these two sides. Now, the OS is pretty much your X, right? The SR is your Y. So now, and this is 60 degrees. Does that look familiar? Right. You're going to have to use 30, 60, 90 to find those missing sides. Okay. And then what are the exact coordinates of that point? Well, if you think about it, this side is going to be your X value. This side's your Y value. So once you find X and Y from here, then you'll write it out. You'll basically just write it as a coordinate. Okay. All right. Now this one here says sketch a unit circle. So sketch a quick unit circle, kind of like we did earlier in the video, kind of noting like what the coordinates are here and here, how many degrees that is, and then use that to help you answer these questions. Okay, I'll draw an axis here. Okay, so it's saying where is there a positive cosine? In other words, an X value. Where is X positive? And a negative sign. Remember, that's Y. So in other words, where is cosine or X? Where is it positive? And where is it negative? And it says sketch an angle. So basically on your unit circle, sketch an angle where X is positive and the Y is negative. Okay, where is the sign? -1. Well, you'll have to figure that out. Where is the angle have a negative cosine? Remember, a negative X and a negative sign or a negative Y. And then an angle that has a cosine of approximately negative 0.9. That's pretty close to negative 1. So think about it. Where would it be really close to negative 1? Or the x be close to negative 1? And the sine, or y, be almost close to 0.4, which is pretty close to 1/2. So where would x be, or cosine, be close to negative 1, but sine also be close to being 1/2? So look at your graph and kind of figure out where would that be on here. Okay, and then the last part, just use the unit circle for this part. Look at your unit circle, your actual unit circle, in the previous lessons or 2 lessons ago, and to figure out what the sign is of this. And what I want you to do is find the sign, find the exact value, and then calculate that in the calculator to figure out the actual decimal value. So you're finding the sign, the actual value, the exact, and the decimal. So you're going to write 2 separate answers here. Okay? And that's it.